using different methods. There are two different methods. One is overlap save method and another one is overlap add method. So this is all the thing we have discussed in the third chapter. Hope everyone have understood that.
Yes, sir.
Yes, sir.
किसी को कोई किसी को कोई डाउट या क्वेश्चंस, एनी डिफिकल्टीज? So if you have any difficulties, you can call me personally or you can put me the message on my WhatsApp personally also, if wherever you are facing any difficulty. Okay. Now can we start?
Yes, sir.
Yes, sir.
So today we are going to start with the fourth unit. Let us note down the syllabus first and then we will move further. Just write unit 4. Its title is FFT algorithm, or simply we are calling it as fast Fourier transform algorithm. Note down this title first. Noted?
Yes, sir.
Next, write down the syllabus and textbooks for this particular chapter. The syllabus is again Radix 2 FFT algorithm for the computation of DFT and IDFT. Radix 2 FFT algorithm for the computation of DFT and IDFT. Then next, decimation in time. That is, in short, we are calling it as DIT. And decimation in frequency. In short, we are calling it as DIF. Finally, we are discussing about the Gorgel algorithm. Goertzel. It is Gorgel algorithm. Just write down the textbook and the reference book. Textbook and reference book. Or
Yes, sir.
next, you write about title of the chapter. You just write about title of the chapter. Title of the chapter. The title you write once again. Fast Fourier transform. Fast Fourier transform. Or in short, you just write FFT. In short, you write FFT. So let us note down the meaning of each term in this. What do you mean by fast? कोई बताएंगे मुझे? What do you mean by fast? Anyone? Now we are writing the meaning of this title. First we will write the meaning of fast, then we will write what is Fourier, and then we will write what is transform. Finally we will write the algorithm. What do you mean by fast? Anybody? कुछ तो बताओ यार. Like simply people are sitting idle.
Capable of moving high speed.
Huh?
Capable of moving high speed.
Capable of moving high speed. Okay. Or
Quickly.
quickly. Okay. और क्या बोल सकते हैं? Any other answer? Yes. I feel this is not that difficult word. Like around 60 members are there. Like I want like 60 answers.
At high rate.
High rate. Keep on talking. Okay, let's write. We just write fast colon. Its meaning is less computation. In terms of processor, if you're talking this way, like fast in the sense in a less time or in a short period, we need to do the more computations. So that is a less computation, or we'll call it as speedily. Someone of you are told that like speedily it is SSSPEEDILY speedily. The next is Fourier. Fourier का क्या मीनिंग है? Next point you write as a Fourier. Yes. Have you heard the name Fourier?
Yes, sir.
Okay, write it down. A name of scientist. Just write Fourier. A name of a scientist. Name of scientist who has invented. Fourier series. Who has invented Fourier series and Fourier transform theories. Who has invented Fourier series and Fourier series and Fourier transform theories. Or
Yes, sir.
next, transform. Just write transform. Right? Convert from one form to another. Sorry. Convert from one form to another. Actually, first 3 chapter का लिखना रह गया है. What to do now with that part? Space वगैरह छोड़े क्या उसके लिए कुछ?
नहीं सर.
नहीं छोड़े ना? आप लोगों ने भी कोई बताया नहीं मुझे. बाकी सब लोग कैसा कर रहे हैं? What the other faculties are doing?
Starting the chapter
Are
as
they
it is.
dictating this? They are not giving this syllabus and all?
No, sir.
So what we will do is in that case otherwise, क्योंकि ये लगता है बाद में like someone will ask that other like why you have not taken all these things. So, okay, let us finish this part and then we will move ahead. No problem. Okay, transform, convert from one form to another. Convert from one form to another is the meaning of transform. The next, algorithm. So otherwise I will do one thing. I will just send you the soft copy of all these things like title, about central idea, complete all chapters, soft copy I will send you. So at the end, if required, we will add it somewhere. Okay.
Okay, sir.
Algorithm, we just write a systematic approach. The meaning of algorithm is systematic approach. Then the complete meaning you just write for FFT algorithm. Just write the word as FFT algorithm. Conversion of FFT algorithm. Conversion of discrete signal in time domain to conversion of discrete signal in time domain to frequency domain, time domain to frequency domain with a less number of computations. Conversion of discrete signal in time domain. Conversion of discrete signal in time domain to frequency domain. Time domain to frequency domain with a less number of computations. With a less number of computations. So this is about title of the chapter. So now let us start with the actual syllabus. So what is the title here? The title of the chapter is what is the title of the chapter? It's fast Fourier transform. Okay. So it is a fast Fourier transform means. So we have discussed already DFT, that is discrete Fourier transform we have discussed. And here this fourth chapter is just advanced part of the DFT part it is. तो अभी इसको फास्ट बोलने के लिए हमें DFT के ड्रॉबैक्स क्या है वो पता करना है, right? So what are the difficulties with the DFT? Then only we can say that this is a fast one. Getting my point? So before going to start with the actual syllabus of this fast Fourier transform, so first we will understand how this DFT is having a drawback, or what are the drawbacks with the DFT, or what the difficulties we have faced with the DFT calculations. So there, and normally we know that this FFT, DFT we are using for like filtering operation. So there we require again, like whenever you want to do this filtering operation, we require the less computations. Suppose आप लोगों को अगर like n equals to if you are having like 32 bit or 64 bit or 1024 bit, then how many computations we require for DFT? So like hundreds of computations are required, like hundreds of multiplication and hundreds of additions we require for to perform this DFT as the number of n increases. Okay. The one advantage with this is FFT is as the value of n increases, the computations are going to reduce. So that we will see like how the computation are reduced with this FFT algorithm again. Okay. So first you write a direct evaluation of DFT. So means what are the difficulties with if we go direct evaluation of DFT, then how many number of multiplications we require, how many number of additions we require, how many number of real additions we require, and how many number of trigonometric functions we require. So that all we will discuss here, and then we will move further. Now you write a title as, just write the title as direct evaluation of DFT, or in bracket you write difficulties with DFT. Direct evaluation of DFT, or simply in bracket you write difficulties with DFT. Noted?
Yes, sir.
Now, we all know the definition of DFT. Yes or no?
Yes, sir.
Yes, sir.
You please write down that. We know the definition of DFT. Our DFT pair was given as x of k equals to n equals to 0 to n minus 1, n equals to 0 to n minus 1, x of n e power minus j 2 pi by n kn, and what is that second formula? Second formula is
IDFT.
IDFT. It is so x of n equals to 1 by n, k equals to 0 to n minus 1, x of k e power j 2 pi by n kn. Okay. Now suppose you have noted this.
Yes, sir.
You noted both the formulas. Now suppose if we expand that equation, DFT expansion, what I can write? If I expand this DFT equation, so that expansion can be written as, so here we have written the formula already, that is x of k equals to, it is x of k is equals to, we have written it this way, that is x of k is equals to the summation n equals to 0 to n minus 1 x of n wn to the power kn. Okay. Or now this I can expand it as x of k equals to, if I expand this, what I will write? I will write it as x of 0 into wn to the power 0 plus x of 1 into wn to the power k plus x of 2 into wn to the power 2k plus dash dash dash. We can write it as plus x of n minus 1 into wn to the power n minus 1 into k. Let us call it as equation 1. I have just expanded this. Understood?
Yes, sir.
Now here, if you look at into this part, so what we will write is, like, let me write it as this first part. So what I am writing this I am writing it as like one complex multiplication, or we are simply writing it as one complex, you just write it completely, multiplication. First point. Okay. Then the second point I am writing it as again. What we are writing for this? This is one complex addition. That is first complex multiplication, first complex addition. Now what we can write for this? This I can write it as second complex multiplication. Understood? And then this I can write it as second complex addition. Right? Then what I can write for this? This I can write it as third complex multiplication. And this I can write it as third complex addition. Okay. Understood?
Yes,
now
sir.
this what I can write? This is n minus 1 complex addition, and this is nth complex multiplication. Nth complex multiplication. Okay. So that means what do you understand with this? So from this, what we can understand is, like, if you want to multiply or if you want to perform each point of DFT, what we require? We require n number of complex multiplication and n minus 1 number of complex addition for one value. Okay. And then suppose if you want to calculate the n point DFT, then we require n into n multiplication and n into n minus 1 addition it is. That's how we can write it is. Have you finished this diagram?
Yes, sir.
Yes.
I will just add one line there so that we can understand it easily. Just write. Here, x of n is the input sequence. X of n is the input sequence, which can be real or complex. Which can be real or complex. And Wn is the twiddle factor. Wn is the twiddle factor or a phase factor. Wn is the twiddle factor or a phase factor, which is a complex number. Twiddle factor or phase factor, which is complex number. Next point you write. For any value of k, in above equation, for any value of k in above equation, we observe the multiplication. And additions involved. We observe the multiplication and additions involved. Next point you write. We observe the multiplication and additions involved. Next point. N number of complex multiplication. Just write capital N. N number of complex multiplication and n minus 1 number of complex additions and n minus 1 number of complex additions are required to calculate x of k for one value of k. Are required to calculate x of k Have you understood its meaning? Have you understood the meaning? What we have
Yes,
written?
sir.
Yes, sir.
अगर आपका एक वैल्यू पॉइंट अगर कैलकुलेट करना है, फॉर एग्जांपल x ऑफ 0 मतलब k इक्वल्स टू 0 लिया आपने, सो हाउ मेनी नंबर ऑफ मल्टीप्लिकेशंस यू रिक्वायर? क्योंकि अगर मैंने यहाँ पे 0 सब्स्टिट्यूट किया, समझो लाइक इफ आई सब्स्टिट्यूट k इक्वल्स टू 0 हियर, देन like 1 point, 2 point, 3 point. Let us take for example if it is a 4 point value, right? अगर 4 point के लिए है तो कहां तक आएगा आंसर? Can anyone tell me? If it is a 4 point, so what we will write? It is going to be like x of k is equals to first x of 0 plus, that is wn to the power 0 plus x of 1 wn to the power k plus x of 2 wn to the power 2k plus x of 3 अगर है तो wn to the power 3k, right? Now suppose if I want to calculate the value of this x of 0, तो उसके लिए क्या expected है मुझे? What is expected if I want to calculate the value of x of 0? क्या फंक्शन आएगा यहाँ पे? तो फर्स्ट x of 0 आएगा, then plus x of 1 plus x of 2 plus x of 3. मतलब यहाँ पे कितने मल्टीप्लीकेशन हो गए अभी? एक मल्टीप्लीकेशन, 2, 3 और 4. How many number of multiplications we require?
4.
4 number of multiplication, that is n number of multiplication. अपना n 4 है, ठीक है? और एडिशन कितना एक्सपेक्टेड है यहाँ पे?
3.
3. मतलब n minus 1 additions are required. मतलब 3 एडिशन मिले हमें. To compute a 4-point DFT, we require for each value 4 multiplication and 3 addition. Understood? So that is the meaning of the first line. Is that clear now?
Yes, sir.
Yes, sir.
Okay. Next you write. Hence we require, just write next. Hence we require n minus 1 complex addition. Hence we require n minus 1 complex addition for one value of k, for one value of k, and for one value of k and n complex multiplication, n complex multiplication for one value of k. For one value of k. Next point you write. Next point. Number of complex multiplication. Number of complex multiplication required for calculating. Number of complex multiplication required for calculating x of k, for calculating x of k for k equals to 0, 1, 2 up to n minus 1. For k equals to 0, 1, 2 up to n minus 1 is equals to. Can anybody tell me the answer now? Number of complex multiplication required for calculating x of k for k equals to 0, 1, 2 up to n minus 1. क्या आंसर हो सकता है?
N complex multiplication.
N complex multiplication for one value of k you require n complex multiplication, right? If your value of k is from 0 to n minus 1, then how many number of multiplications you require?
N minus 1.
If the value of k is 0 to, chalo, let me ask you here, like suppose k equals to 4 है, like 0 हमने calculate किए, right? So if n is equals to 4, I have calculated for 0 कितने चाहिए हमें? For 0 how many requires? We require कितने एडिशन है? For 0 value we require 3 addition and 4 multiplication. ठीक है, और 1 के लिए सेम आएगा, राइट, 2 के लिए सेम आएगा और 3 के लिए सेम आएगा, बराबर। 4 पॉइंट वैल्यू आपको कैलकुलेट करने के लिए इतने एडिशन और इतने मल्टीप्लिकेशन चाहिए। Getting my point? So this is 3, not 4. This is 3 and this is 4 और ये प्लस है, डोंट गेट कंफ्यूजन हियर, बराबर। तो कितना हुआ अभी, अगर आपको 4 पॉइंट वैल्यू अगर मल्टी कंप्यूट करना है डीएफटी का, तो कितने मल्टीप्लिकेशन चाहिए आपको?
4.
हाँ, if you want to evaluate a 4 point DFT, how many number of multiplications you require?
16.
16 it is, very good. And how many number of addition?
12.
how many number of addition? 12 additions. मतलब अभी 4 पॉइंट अगर आपको कैलकुलेट करना है, यू रिक्वायर 16 मल्टीप्लीकेशन एंड 12 एडिशन। नाउ इन जनरलाइज्ड मैनर 16 कैसा है आपका, n इक्वल्स टू 4 है बोले तो 4 इंटू 4 16 आ गया, राइट। गेटिंग माई पॉइंट?
Yes. Yes, sir.
नाउ कैन यू टेल मी द आंसर?
N square.
Calculate n square, it is very good. So that means just write that. The number of complex multiplication required for calculating x of k for k equals to 0, 1 up to n minus 1 is equals to n into n, that is n square. Just write it as n into n, that is n square. Is that clear to everyone? How this n square is coming?
Yes, sir.
Yes, sir.
Okay, call it as equation 2. Just give the number as equation 2. Next point you write. Next point. Number of complex addition required for calculating x of k. Number of complex addition required for calculating x of k for k equals to 0, 1 up to n minus 1. For k equals to 0, 1 up to n minus 1 is equal to, can anyone tell me the answer now?
N into
N
n
minus
minus 1.
Huh?
N into n minus 1.
Yes, it is n into n minus 1 क्योंकि हमें 4 पॉइंट वैल्यू कैलकुलेट करना है और हमें 12 आता है, मतलब 4 is n into n minus 1, 4 minus 1, so 4 into 3, so 12 additions are required. So you just write that equals to n into n minus 1 or simply equals to n square minus n. N into n minus 1 or simply equals to n square minus 1. Okay, so hope you all understood now. So this is what already we have discussed in an MCQ question yesterday. Number of multiplication required to compute a complete DFT. n square आंसर आप लोगों ने बताया था, बराबर? Yes or no?
Yes,
Yes,
sir.
sir.
Yes, sir.
In yesterday's MCQ also we have discussed. You may expect a MCQ question on this part. And then the number of additions required for computation of n point DFT, that is n into n minus 1. Hope you all have cleared now. आता विचार करा मग, right? So for computing 4 point, we require 16 time multiplication and 12 time addition. Suppose if we have like 32 point, n equals to 32 point, तो कितना होगा? How many multiplications you require? कोई बताएंगे मुझे अभी? So you may expect such questions for MCQ also again. If we have n equals to 32, then how many number
32
of
into 32.
multiplications you require? And how many number of additions you require? Multiplication, like complex multiplication required are how much?
1024.
32 into 32. Someone आंसर कितना है इसका?
1024.
1024.
1024 multiplications were required. What about addition? Addition क्या आएगा अभी?
992.
992.
That is 32 into 33, right?
32 into
बराबर.
31.
Addition is, sorry, 32 into 31. So we will get the value as 32 into 31. How much you are getting?
992.
992 additions were required. You think of this. Is it possible manually doing this? Manually ये करना possible है क्या अपने हमें?
No.
Right? So this is very difficult for doing this. Means as the value of n increases, the complexity of the computation in DFT is increasing. So this is the main drawback with this DFT. So because of that, we are moving toward this FFT algorithm. Hope you understood now.
Yes, sir.
Yes, sir.
Yes, sir.
Now, next point you just write. Next title you just write. Next one, just write this as a title. To determine number of real multiplications, and you all may expect a MCQ question on this particular part. To determine a number of real multiplication, real addition, and trigonometric function. You just write down these equations. This is already we know that. Definitions of DFT we are writing. Just write down the definition. Or
Yes, sir.
so any difficulty in understanding this? Just I have written the definition of DFT. The second, that is equation 1, we are writing the definition in terms of twiddle factor, that is Wn to the power kn. And as we all know that any sequence is a combination of real number as well as imaginary number. Okay. So any difficulty in understanding this?
No, sir.
No, sir.
Now let's write one more line. Equation 1 can be written as, we just write equation 1 can be written as, equation 1 can be written as, just write down this. I have just substituted the value of x of n and omega n to the power kn value, and separated the real numbers and the imaginary numbers. Just write this. So first I have substituted the value of x of n and omega n to the power kn, and then separated the value in terms of real number and the complex number, imaginary number. Or
Yes, sir.
can I move further?
Yes, sir.
Okay. Just note down this. Or
Yes, sir.
Yes, sir.
now what you are understanding with this? So here this is what you can say one complex multiplication we are doing. So xr of n plus j xi of n is multiplied with wrn to the power kn plus win to the power kn. Right. This is I think j is missing here. Okay. Just write here j. क्या है क्या वहाँ पे? This j is expected here. ऐसा ही लिखेंगे सब लोग. wn to the power kn. What you have written? Please do this correction. Wn to the power kn equals to what you have written? Hello.
WRN to the power KN plus J WIN to the power KN.
लिखे है ना सब लोग?
हाँ सर.
Okay, so here also you just do it as like WRN to the power Kn plus J WIN to the power Kn. Now this is what we are calling it as simply one complex multiplication, right? So if you multiply this, we are getting this way. So that means with this diagram, what we can understand is, so one complex multiplication is converted into 4 real multiplication and 2 real addition. Getting my point? मतलब एक वैल्यू अगर आपको परफॉर्म करना है तो you require a 4 real multiplication and 2 real addition. Okay, we just write it now. That means one complex multiplication is converted to, just write it first. One complex multiplication is converted to one complex multiplication is converted to 4 real multiplication and 2 real addition. Or
Yes, sir.
one complex multiplication is converted to 4 real multiplication and 2 real addition. After that, you just add one line. We know that for each value of k, there are n complex multiplication. For each value of k, there are n complex multiplication. Hence, we can write. What will be the answer here? Can anyone tell me? एक मल्टीप्लीकेशन अगर है तो आपका n रियल मल्टीप्लीकेशन, सॉरी 4 रियल मल्टीप्लीकेशन एंड 2 रियल एडिशन आ गया. सपोज आपका n नंबर ऑफ मल्टीप्लीकेशन है, then how many number of real multiplications you will get and how many number of real additions you will get. Yes, anybody?
4n.
Yes, it is 4n because like n number of multiplication means we need to write like 4n real multiplication and 2n real addition. एक value के लिए it is like 4 into 1. 4 into 1 real multiplication and 2 into 1 real addition. If n number of multiplications are there, complex multiplications are there, then we require 4n real multiplication and 2n real additions. Just write down this. For each value of k, n complex multiplications are converted to, for each value of k, n complex multiplications are converted to Any doubt here? Any confusion? Anybody is having any questions?
No, sir.
Please feel free to ask me the questions if you are having any confusion at any point. For each value of k, n complex multiplications are converted to 4n real multiplication, 2n real addition. 4n real multiplication and 2n real multiplication. Real addition, it is not multiplication. Next point you just write. Have you finished this?
Yes, sir.
For complete DFT, next you write, for complete DFT, in bracket you write n into n. For complete DFT, n into n, complex multiplications are converted to n into n, complex multiplications are converted to What is the answer? For complete DFT, n into n complex multiplications are converted to. Yes? What is the answer here? Anybody? Am I audible?
Yes, sir.
So what is the answer here? अगर आपको complete DFT calculate करना है, that means n into n complex multiplications if you are having, then what will be the real multiplication and what will be the real addition?
4n square.
4n square.
Yes, it is 4n square real multiplication. And what about
2n square real
2n
addition.
square real addition? Yes. Please write down this. Is equals to 4n square real multiplication and 2n square real addition. You may expect this as a MCQ question here now. So for complete DFT, the number of complex multiplications, how many real additions are required and how many real multiplications are required. Understood? Any confusion here?
No, sir.
No, sir.
So this is the way how we have calculated real multiplication and real addition. The next title you just write complex addition conversion. For complex addition conversion, like how many number of additions are required, we need to understand. Just take this diagram. Complex addition conversion. Take this diagram. Is my screen is visible properly?
Yes, sir.
Okay. So you just take this diagram. A plus JB plus C plus JD can also be written as A plus C plus J P plus D. So this A plus JB plus C plus JD, we are calling it as simply one complex addition, which we are converting it into how many real number of additions? One complex addition is converted to two real additions. Have you finished the diagram?
Yes, sir.
Okay, maybe I need to stop it here because it will not get complete. The time is getting completed. We will continue further in the tomorrow's class again. So you please mark your attendance. Until then, if anybody is having the questions, you can ask me.